Okay, now this worksheet number 7, is Introduction into Laplace Transform. So the first question number 1, you wanted to use the definition of Laplace to find the transform of this e to the 2t for t between 0 and 3, 1 when t is more than 3. Now the definition of Laplace is to integrate from 0 to infinity e to the minus st into the function dt. So you have two different functions here. So you need to integrate from 0 to 3 first, e to the minus st into this, because 0 to 3, this is your function. And then you integrate from 3 to infinity e to the minus st times 1 dt. So basically you're integrating from 0 to 3. Now you add the exponent. This plus this becomes negative s plus 2 t dt. And times 1 would be just e to the minus s dt. So we integrate this one. The integral of e would be itself over whatever the multiplier is. Whatever the thing that you have in front of the t. And you need to plug 0 and 3. Same story here. Integration would be itself over the multiplier, the number in front of the t, and here we plug infinity and 3. So you plug 3, you can write this, instead of negative s plus 2, you can make it 2 minus s and 2 minus s. So you have 2 minus s. You're going to plug 3 first. And you have 2 minus s. You're going to plug 1. This is the result of the first one. Here, same story. You plug infinity. So minus infinity over minus s minus. You plug 3. Becomes 3s over negative s. Now you can take the 3 inside, so that would be 6 minus 3s over 2 minus s, and e to the 0, you know, is 1. E to the infinity, e to the minus infinity is 0, and minus minus becomes plus. So this is here your final answer. E to the 6 minus 3t over 2 minus s negative 1 over 2 minus s, and e to the minus 3s over s. This is if you're asked to do it using definition. You'll see that with the Laplace, I also sent you the rules of Laplace. I forgot this, it's the last sheet that I sent you, but I forgot it on the table. I'll go bring it quickly. No, in fact, here it is. Yeah. So I sent it to you. It has all the Laplace transformation. So it's, we will talk about the rules now, and we will apply them to some of the questions they provide. So question number 2, number 1. So you're going to do Laplace transform or transformation for t to the power 4 cosine of 3t 3e to the minus 2t. So Laplace transform for ft would be Laplace transform of all three. T to the power 4 cosine of 3t and 3e to the minus 2t. Now we take the Laplace inside, so you're going to do Laplace transformation to t to the power 4, Laplace transformation for cosine, and Laplace transformation for the 3e minus t, or minus 2t. We start with this one. If you look at the rules, if you look at the first column, for this one, I'm going to highlight it with a different color. For this one, we're going to use this rule. If you have 2 to the n, this transformation would be n factorial s to the n plus 1. So your n is 4, so the rule says it's 4 factorial s to the n plus 1, so n is 4 plus 1, 5. So this is the result for the first one. For cosine, I'm going to use the rule, and it's number 5, cosine of kt, you have s over s squared plus k squared. So for this one, you put the letter s and s squared, and this number in front of the t squared. Now we do this one, and for this one we use rule number 5. When you have e to the at, the transformation would be 1 over s minus the a. There is a constant 3, so you put it on top. Your a is minus 2, so it would be s minus the minus 2. Now the final look of this 4 factorial, as you know, is 4 times 3 times 2 times 1. That would be 24 s to the power 5. This is s over s squared plus 9. This is 3s plus 2. So this is the final answer for the transformation of this, and you just apply the rules. And the trick here, some of the rules are a little bit more complicated, so the idea is to know how you can apply the rules. For this one, it was pretty much straightforward, so you don't worry about it. Okay. So we go and do the next one, number 2. H of t equals 1 minus E3t all squared. Now, you'll see that none of the rules match this, and he gave you a hint that to do this, you better expand this first. So it's this times itself. 1 times 1 is 1. 1 times this is negative 3t. This time this is negative E3t. And this time this will be plus E60. That will be 1, 2e to the 3t, e to the 60. So this is the result of expanding this. Or you could do it quickly. You know, when something's squared, you square the first one, you multiply first, second, and 2, and you square the second one. Either way, this is the function after expanding. So you're doing the Laplace transformation for h of t, which is the Laplace transformation for all of this. So you have Laplace transformation of the number 1, Laplace transformation of minus 2e3t, and Laplace transformation for e60. Again, looking at the rules, because I just want you to feel more comfortable with the rules. For this one, it's the first rule. If you have 1, it becomes 1 over s. So this one simply becomes 1 over s. For these two, since they're pretty much similar, we're going to use the same rule, and that's rule number 5. When you have e to the at, it's 1s minus a. So for the first one, you have a constant 2, and then you go s minus the value of a. And here, the value of a is 3. And for the last one, there is no constant, or the constant is 1. And here you have s minus the a, and in this case, it's 6. Now, usually, I don't know what Diego wants, but usually, when it's something like this, we prefer if you find common denominator and represent it as a one function. So, to do the common denominator, you can take this denominator here. You need to multiply it by s minus 3, and s minus 6, and therefore you have to multiply the top by also s minus 3, s minus 6. This one, you need to multiply by the other two, s and s minus 6, so s and minus 6 would also be multiplied by the 2. This one is s minus 6, we need to multiply it by the other two denominators, the s and the s minus 3, so the 1 is also going to be multiplied by the s and the s minus 3. So, common denominator between all of them is s minus 3, s minus 6. Here, you can ignore the 1. S times s is s squared. S times minus 6 would be minus 6s. Minus 3 times s would be minus 3s. And minus 3 times minus 6 is 18. Here we have minus 2s times s minus 2s squared. Minus 2s times minus 6 would be plus 2s, 12s. You can ignore the 1, s times s is s squared, and s times minus 3 minus 3s. Now we look at the top, you see s squared plus s squared as 2s squared minus 2s squared, they all cancel. You look at the s, 12s minus 6s would be 6s, minus 3s would be 3s, minus 3s. You'll see that all the s's also cancel each other. So your final answer for the expansion is 18. S minus 3, and s minus 6. So you could leave it like this, but again, in Laplace we prefer if it's easy only, to combine them into one fraction. Good? Okay, so number 3. Now you have a t into sine squared t. If you look at the rules, there is nothing involving sine squared. There is only something for sine and cosine, but no square. And they also give you a hint. They tell you use half angle identity. Half angle identity, if it's cosine, it would be 1 cosine double angle over 2. And if it's sine squared, it would be 1 minus cosine double angle over 2. So sine squared, 1 minus cosine double angle over 2. So first we use the half angle identity. So this is like 1/2 and cosine 2t over 2. Now take the t inside. This is 1/2 of t, and t cosine of 2t over 2. Okay. Now, to do the Laplace transformation for this, again, it would be Laplace transformation of the first one plus Laplace transformation of the second one. Okay, now looking at the rules, forget about the constant, that's t, so that would be the second one. So for this one, I'm going to use the second one, and the second one states if you have t to the n would be n factorial s n plus 1. So your n is 1 and 1 factorial, so it would be, there's a constant half, this is 1, so 1 factorial, which is eventually 1, and s, and since this is 1, it becomes 1 plus 1, 2. So the final answer for this, I'm just going to allow some space. So final answer for this would be 1 factorial times 1, 1, and s squared, because n is 1, times 2. So this is the result of the first one. But this one is a story. It's a long story, and there are 2 ways of doing it. So I'm gonna allow myself some space. Okay. If you look at the rules, because I'm not sure what rules of Laplace he's gonna give you, but there is what's called a general rule for t times cosine or whatever, and that would be rule, it's toward the end, it's this rule. When you have Tn f of t, let me use the different color so you know that I'm writing the rule here. When you have Tn f of t, so t to any exponent and the function of t, the Laplace transformation for this would be minus 1 to the n dn over dsn f of s. I'll tell you what, it's a very good rule. It helps you with any type of t into something. When you have a multiplication of, even when it's squared, cubed, anything, when you have anything like this, you apply this rule. Okay. So first of all, I'm going to write this way. I'll put the t by itself times, and f of t would be everything else, the minus cosine of 2t over 2. Now, if you notice, comparing this to all of this, n is 1. And this here, all you need to do with this is find the transformation. So here, I need to find the transformation of this. So it's basically you're finding the transformation of ft, which is this part. And that would be rule number 5. The rule says when you have cosine of kt, it's s into s squared k squared. Okay. There is a constant minus half. And then in the bottom you go s squared plus k, which is 2, squared over s. So the expansion is s on top. You can put the negative with it, doesn't matter. And in the bottom you have 2 s squared, and 4 times 2 is 8. So this is the expansion of this. But this is this part. This means if you have 1, you need to find the first derivative of the expansion. If this is t squared, then n is 2, then you find the second derivative of your expansion. If it's 3, you find the third derivative of your expansion. Since this is 1, I'm finding the first derivative of my expansion. So d over ds of my expansion would be the answer. So we start finding the derivative. Of course, this is quotient. Derivative of the top is minus 1 into the bottom function. Minus derivative of the bottom into the first function. Over the bottom function squared. I'm gonna erase some of this. Now take the negative inside, minus 2s squared minus 8 plus 4s squared over 2s squared 8 squared. Four s squared, 2s squared, that's 2s squared minus 8 over 2s squared plus 8 squared. Now, you can take 2 as a common factor here. You can also take 2 as a common factor. But since the 2 you take common factor is squared, is like taking 4. And the 2 and the 4 cancel, so the final answer would be this. Squared. Now, I'm just making sure why my answer is positive, but the answer when I did it to you was negative. I think because I had an extra negative outside for no reason. Yeah, so we'll make it positive. The answer must be positive. So yeah, this is the right answer. So the transformation for this would be s squared minus 4 s squared 4 squared. So this is the final answer. It's a little bit long, but this is how you do it when it's t. I'm also going to show you a different way to do it to get to the same answer. There is a rule, but maybe he doesn't use. This rule is not so famous, but again, I don't know if he uses it or not. The rule says, I'm going to erase this, I'm going to write the rule. When you have Laplace transformation for t cosine at, then it's s squared a squared s squared a squared squared. So this is the Laplace transformation rule. So if you follow the rule here, a would be 2. So there is a negative you put outside. So it's s squared minus 2 squared. And in the bottom would be s squared. 2 squared is 4 squared. And you get the same answer if you notice. I still don't know why I'm getting negative here. And it's not negative. Let me just have a quick look at it. So we're doing the Laplace transformation for this using the rule. Yeah, okay, we forgot. Yeah, I know what's going on here. In the rule, when we found the derivative, not only the derivative that you need to multiply it by minus 1 to the n. So this must also, after you do the derivative and all that work, you need to multiply by minus 1 to the n, which is 1. So that's what made it negative. So it would be s squared, and minus 1 to the 1 is minus, so s squared minus 4 s squared plus 4 all squared. So this is the answer for the first question. But again, I don't think he wanted you to use the rule. I think he wanted you to use the rule I gave you, because this rule is more general. Because what if this is cubed, or to the power 4, or to the power 5? This one is only limited when t is to the power 1. So it's not very helpful. Okay. Now we do question number 4. You have a function e to the minus 2t cosine of this, and t squared et. And again, you're doing Laplace transformation. So Laplace transformation for this would be Laplace transformation for this one minus this one. As you know, when you have something minus something or plus something, you can do the distribution. So this is like Laplace transformation of this into cosine plus Laplace transformation of this whole thing. But I'm going to put the ET first. And then the negative t squared. Now, this is called shifting. The shifting rule would be in your formula sheet. You'll see it. It's when you have e to the at f of t. So when you have e to a certain number t and a function of t, e to a certain number and a function of t, the rule states what is it? It's the fs minus a. So you need to do the shifting for s minus a. The idea is simple. When you have e to a certain exponent t and then a function of t, and the same thing here, this is the function of t, this is the function of t. You need to do Laplace transformation for this, for the function of t, but we're going to do a shift. The shift would be s should be replaced by s minus a. And since a is minus 2, then this would be your shift. So you do Laplace transformation to the function of t, but you need to shift according to this. So s becomes s plus 2. So look at this one. We do Laplace transformation for minus t squared, and the shift would be s into s. A is 1, so you replace it by s minus 1, meaning the cosine root t, you probably know the rule now. When your cosine of kt would be s squared k squared. So here we go, s squared and k squared, and remember, we still need to do the shift. For the t squared, I'm going to use the rule n factorial Sn plus 1. T to the n, sorry. Which is the second rule, n factorial s to the n plus 1. So there's a constant minus 1, 2 factorial, and exponent Sn plus 1, so that would be 2 plus 1 cubed. But you still need to shift s minus 1. Now the idea of shifting, all you need to do is, wherever you see s, replace it by this. So this would be s plus 2, this would be s plus 2 squared, and root t squared is 3. Root 3 squared is 3. 2 factorial is 2. S cubed would be s minus 1 cubed. So this is the final answer for number 4. This is the idea of shifting, And again, the idea of shifting is when you have e with a function of t. When you have e with a function of t. I think that it will get more complicated later on, and there will be also, eventually, you'll have what's called inverse Laplace, is when they give you this, when they give you the answer, and tell you, can you figure out what it was? So you're working backwards. You're given the answer, can you figure out what the original function is? So this is a good introduction, so please review and don't wait to the last minute. Review all the videos and I'll see you again for the next one. Okay? Bye now.